Hello and welcome back to episode 5. So today it's probably going to be pretty short, but I'm just going to basically rewrite the function we just wrote. In light of the fact that I thought about it a little more and I realized that it's quite possible that this is going to be a sparse matrix, and so I don't really want to carry around an entire list of integers where that list is size m plus n minus 1. I'd rather just do an association list like before. And so I've taken the liberty of redrawing this thing with a k equals 3. So basically the only elements that are set to 1 in this dot plot are the ones that begin a block of 3 matching elements. And then I change the numbers of the diagonals as well. Okay, so what that means is instead of having a list of ints, I'm going to have something like a diagonalScores. Let's get it up here. And it's a map from int to int, where the first int is the diagonal index, and the second int is just the number, the score. And let's see. So my initial value is map.empty now, and for that reason I can get rid of this m. I still need this n because of the call to diag index, wherever it is. Yeah. This is going to stay the same. This is going to stay the same, and oh, sorry, this is not going to stay the same. This is going to be diagonalScores, as is this. Okay, so where are we now? Increment diags. I'm mapping over this list of integers, and for each integer I basically want to and it actually may have been a good idea to keep this function around for just comparison purposes later on, because really I have no idea if this thing is going to be a sparse or a dense matrix. So if you're following along, you might want to just comment out the entire function, keep it around. But anyways, what I want to do with this index is modify the state. And I want to call it just with default, where the default value is just a 1. If it doesn't exist, if it's already there, plus 1. Oops. And the key is my index. And that's as far as I need to go, because we're in the state monad. So the lens went away, and so we can get rid of that lens library. Goodbye, lens. Alright, what's going on here? Couldn't match type map. Oh. Okay. And finally, avoid lambda. Avoid lambda, what do you mean? Yeah, so let's try this. And that's probably gonna, I don't think I have my precedence quite right. Let's try that. Yeah, okay. So this compiles, but before I even test it, I also meant to eventually go back and make this toList a little nicer, because the only reason I have it is if you look at the type signature of mapm from wherever it's from, Control.Monad. I know this isn't very easy to read, but this second argument right here is a list. But I don't have a list, I have a map. And so I cannot use this version of map_m. There's a more generic one in Data.Traversal, which allows me to traverse over any traversable. And a Data.Map is an instance of traversable. Okay, so this allows us to no longer cast this as a list. So this type signature is going to change, and now I just have a dot plot, so that's much nicer. And I also... So the very first thing I need to do when I'm mapping over this map is I'm going to have access to the values. So I no longer need to call second on the first element of the list because I don't have key value pairs anymore. And I need to change this to trav.mapm. So there is no trav.mapm underscore. That's fine. All we're going to have to do is something like return unit. And this is a regular old mapm because I have a list of ints here. So I'm going to try compiling it, and no, it doesn't work. No, it doesn't work. Couldn't match type unit. Yeah, so I have to reintroduce the dot plot here. And I'm just going to call it dot plot tick. Okay, so there's actually a little nicer way to do this. I'm not getting a compiler warning, but if I change this to not use do notation here, and I just do it like this, then I think my compiler will complain at me. Use void. So I'll use void. And there. And the type signature of void is right here. Well, that's super ugly. Let's look at it in GHCI. Hooray! Okay, so am I done? I think so, but let's try it out. Yeah. Alright, are you gonna let me copy and paste with my mouse today, Vim? Oh shit, that didn't work. I'll just do this the old-fashioned way. No, I won't. Damn it! Yes, I will. Oh shit, there we go. Okay. Sorry, guys and girls. Probably guys, you know, let's be honest. CGT. Guys and mom. How about GAT? I think I got like 9 views on my previous video, so sick. ATC. But I do it for the love of it. Okay. And let me just make sure my K is 3. No, it's not. Okay, and now what am I doing again? Diagonal scores. So Okay, so let's take a look. According to this thing, yeah, that is not what I have. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6 gets 2. Oh. It is what I have. Sorry, there should be a 0, by the way, because, yeah, I don't know why that was a 1. So, it looks like, I don't know how this happened, but I have like an I minus j where I should have a j minus I or something like that, because apparently this is diagonal 0 now. And because you can see that diagonal 0, 1, 2, 3, 4, 5 has a value of 1, and 1, 6, 7, 8, 9, 10 has a value of 4, 11, 12, 13, 14, 15 has a value of 2. So it works. I'm just going to end this video here, and I'll investigate exactly why this is happening. I don't think it's too important because my decision was arbitrary anyways. So thank you for watching, and next time we'll move on to part 3.